We learned about enthalpy before. It is stored heat in a substance, and it depends on both the internal energy of a substance, which is affected by temperature, and also the pressure volume of a gas, because this can do work. We're going to do something to simplify that and say that during a chemical reaction, the change in enthalpy of the substances is equal to just the change in energy of the internal energy, and we can do that if we assume that pressure and volume remain constant. So the change in enthalpy for a reaction is the amount of heat that is absorbed or lost during a reaction, and because we're considering pressure volume constant, it's the same thing as Q for the reaction. So if the change in enthalpy is negative, it means that the substances are releasing heat and that the reaction is exothermic. If the change in enthalpy of the substances is positive, that means they are taking in heat, and so in other words, heat is absorbed by the substances and the reaction is endothermic. So we could look at this graphically and see. So if the reactants have more energy stored within them, so this is stored heat, than the products, that means that during the reaction, the reactants or the substances are releasing heat. This is like when you have a fuel like gasoline, it has a lot of energy stored within it. The products, CO2 and water, don't have as much energy stored within them, and so heat is released. The amount of heat released is the difference between those two values. On the other hand, if you have reactants that have a low energy, low amount of stored heat, and they become products that have more energy, well, that's going to require heat being taken in. So this reaction is exothermic, with the amount of heat being the difference between the reactants and the products, and this is endothermic, meaning the reaction takes in heat. So this one will warm the surroundings because the substances are giving off heat, whereas this one will cool the surroundings because the reaction is taking heat away from its surroundings. This is a bomb calorimeter. It's a way to see how much heat is given off during the combustion of some kind of fuel. And you may do an experiment with one of these if you take physical chemistry in your junior year. It's kind of fun. We did it. We put some food, a food sample, in this container, and you pump in oxygen. And this is a big calorimeter where there's circulating of the water and a thermometer, and you keep track of how much the water warms up, and you can tell how much energy your food gave off when it was burned.